we're always inspired by nature and using nature as a starting point. So we can use the most advanced technology, whether it's robotics or parametric design, using algorithms, AI. Regardless of the technology, our goal is to create something that's beautiful and it just works as far as simplicity, and there's kind of a synergy in the work that we do. So we're hoping to use this advanced technology to create beautiful forms in nature and having everything work together really well.
Hello everyone, my name is Izumi Tanaka. I am a podcast host of Home Green Homes. Today I have two gentlemen, Joseph Sarafian and Ron Culver. And Ron and Joseph are co-founder of Found Design, an architectural and design firm based in Los Angeles. And I am going to have them tell us who they are and what they are here to talk about. They have some very innovative design technologies that they've created that we're going to be discussing. So Joseph and Ron, if you can take one of you each, take your little time to tell us who you are and what your backgrounds are. And I'm usually very interested in knowing what originally got you into the space of architecture and what you're doing. Like, if there was any early childhood influence or anything like that, I would like to hear from you. So let's start with Joseph.
Yeah, I'm Joseph Sarafian. I'm a licensed architect in California. I began my career working for architecture firms based in LA, Synthesis Design and Architecture, Perkins and Will, Fred Fisher and Partners. I went to USC for undergrad, grad school at UCLA, where I met my business partner, Ron. And we both kind of met in grad school in kind of in different places in our lives. I was kind of an entry-level designer. Ron was a seasoned architect and contractor. And I had kind of this background in computational design, parametric design, so a lot of complexity and in the kind of technology side in architecture. And so I was interested in getting to use 6-axis robots that they had at UCLA and some of the hardware and things like that. So when we met, it was kind of this collision and on different trajectories, but we found pretty quickly that we complement each other's skill sets. And Ron and I just kind of hit it off after that. And our first project was a concrete structure with robotics for Amazon.
Wow.
That was a 15-foot tall structure. And then since then, we've done a number of other kind of architectural installations as well as residential and a lot of other small projects that keep our architecture office and our architecture appetite satiated. So I'll let Ron introduce himself too.
Okay, let's hear from you, Ron.
Sure. I got into architecture from music, as everybody does. Not at all. I had an unusual career trajectory, but it all really is a creative-based orientation. And so it went from playing with paper models as a child to becoming a musician to becoming a contractor to becoming an architect.
Wow.
And so I have sort of hands and feet on the ground kind of approach to design as because I've built a lot of the same things that we design and detail in the work that we do. And of course, when Joseph and I were playing about with 6-axis robots in grad school and after, we were doing most of the building as well, despite the concept that maybe the robots would be helping us a bit more. But we got a lot of precision out of them, and we provided the physical impetus to do these really unusual projects that was with the thesis of mass customization, that there was no premium to design different objects, that they all cost the same. And so that's what we were able to use to create the Mars Pavilion and another exhibit that's now in the Australian Museum of Science and Technology Austrian museum, excuse me, not Australian, and in Vienna, and so we took this natural concept into residential design and multifamily design, of trying to design without any premiums for customization. And that got us into the idea of computational framing, and also using prefabricated kit of parts. Joseph, you want to start with those two?
Well,
Sure.
yes, so it's very intriguing. So at one point, did you guys decide to partner up and form this form found design? And tell us, I mean, it sounds very intriguing, that especially
Oh,
the no premium on the customization part,
let
right?
me just let me say one sentence about
Yes.
forming up. I When we were at grad school, I looked for the smartest person in the room.
Oh, wow.
So did I, and we found each other.
That's a good
Um,
compliment for you, for you.
so we began this journey in, working on the same project and realizing pretty quickly, the skill sets that we had were very complementary.
Mm,
I could digitally model virtually anything. Ron could build virtually anything.
mm.
And I think our personalities were both very relentless in our approach to design and iterative thinking. And so we'd go back and forth on a lot of these kind of design ideas, often going, arguing about things and realizing, okay, what we just came up with is better than what either of us could have done in the beginning on
Mm.
our own. And so that's, I think, the mark of a true, good partnership. And then we got this research published coming out of grad school. We were using robots to position flexible fabric and then pouring concrete into that fabric. So we're using the precision of robots and the dimensional freedom of fabric to create these customizable concrete geometries that we
Wow.
felt were really compelling. And so it was published in a journal, and so we got to go to Australia to give a talk at the Robotics and Architecture Conference. Apparently, there's a whole community of architects that are exploring with robots on how to automate construction and how to create customization and things like that. So after that, it was published on Dezeen, and after that, it was, all these feeder blogs publish it. And so Amazon reached out to us. They had seen one of the blogs and they asked us to build a 15-foot tall concrete structure for their invite-only conference in Palm Springs. Jeff Bezos hosts a conference, and they collect any kind of thought leaders in robotics, automation, space exploration, machine learning. And so we said, that's great. Why are you approaching us? They said, well, you're using robots in a unique way, and we'd love to see the structure built, and we'd love to see a demo of how you use robots to cast concrete.
Mhm.
And so we jumped at the opportunity. I told Ron there's no bigger stage to either succeed or to fail on. So we have to pull through on this. And we eventually we told them, okay, we're gonna both have to take time off of our day jobs. I was working at Perkins and Will. Ron was working at Michael Filonis in Santa Monica. And so we took time off, rented a warehouse in downtown LA, this dingy, I think we were subleasing a sublease, a tiny little warehouse where the only entrance was from this back alley with cracked road, and
Oh my God.
very difficult to get robots into a warehouse
Yeah.
size. But we were able to get two large 6-axis robots on loan from ABB Robotics, because we told them we're going to be presenting your products in front of a lot of your existing clients and future clients. Ford, Toyota, the CEOs were all at this event. And
Wow.
so it was an interesting opportunity for us to be able to kind of pull together these different industries for this project, and being as lean and kind of frugal as possible, which I think is built into the Amazon ethos as well.
Mm-hmm.
So we built this project, and then kind of along the way realized we should form a company if we're gonna, bill for this and treat this professionally. So we launched our company really for that project, and then after the project was over, we said, well, there's other pavilions we can go after, but we're both
Mm.
architects. We're both, we're not roboticists. We're not concrete experts. So the kind of how that evolved is we said we'd love to be an architecture firm, but in the background have this line of research, this
Mm.
design research that goes on that we can still pursue, and then allow that to inform the architecture and built work that we do.
Mm.
So it's not that we're completely branching away from it. It's kind of growing from it, and it's still in our DNA. I think the
Mm.
complex geometry and using the forms of nature to inform the architecture.
I love that. It's so fascinating. So obviously this was a major success for you, right? With the Amazon pavilion. I saw that it's on your website, and
Yeah.
obviously that was a big success, and hence formed the form found design. So tell me about what form found design is doing. And we met at the wildfire recovery workshop recently, and your presentation caught my attention because we were talking about the resiliency and fire resistant and things like that. So I would like to hear about how you evolved into doing more residentials, and I know that you do other commercial buildings and different forms of structures, but I would like to mainly talk about the residential projects that you may have been endeavoring.
Yeah. Ron, do
So
you want to take that?
yeah.
Sure. Yeah, so we've throughout all of this, we've had our hand in residential design,
Hmm.
it be multifamily or single family,
Hmm.
and but we wanted to apply the technology that we had been studying and using
Hmm.
in some ways for towards this. And so there was a couple of technologies that we've employed on different projects. One is computational framing, which I'll let Joseph talk about. Other is metal buildings or Butler building type structures. But one of the things that we're trying to do is really create fire resilient homes. And we've done a lot of research into that. We've designed fire resilient homes in the past for the Woolsey fire.
Hmm.
And in looking for ways to use non-combustible materials,
Right.
so not using wood frame structures,
Hmm.
and ways to harden the home from wildfire ingress into the building in all surfaces, the roofing, the any crawl spaces or attics, and venting that goes into the building,
Hmm.
exterior surfaces, and one of the most vulnerable areas, which is glass windows and doors.
Right.
And so we have many different techniques that we use that in this design, sometimes even shuttering the building with metal um, to protect it, metal roofing,
Mm.
uh, stucco or metal siding exteriors, and looking at insulation that doesn't melt under heat, all sorts of things like that. And we actually also did research after the Palisades fires because they did something that was unique, which was to photo document all the buildings that had survived or had damage.
Hmm.
And so we used that database to determine for the buildings that had slight damage, what caused that damage.
Hmm.
To be able to look at a photograph and say, this window failed and the fire got into that building that way. They were able to put the fire out, but we can
Hmm.
see that that was one failure, or there was a vent that failed, or there was wooden eaves that were exposed, or a gutter that melted and or the foliage next to the building. It was very informative. And
Hmm.
so that's one of the reasons that we feel very strongly that we can help to prevent future homes that we design
Hmm.
from being as susceptible
Hmm.
to wildfire and to the conflagration that comes when you have multiple homes burning in a subdivision or a residential setting.
Hmm.
So one of the projects that we did employed a metal building frame that I talked about, which
Hmm.
is, and so there's two theses here. One is which is fire resiliency. The other is economical or efficient design systems. And so to that end, we do partial prefabrication. We design for this. We don't do it. We're not prefabricated builders or modular builders or anything like that. But we design with these systems and connect the contractors to the fabricators. And one of them was a metal building that used that was a very small lot in Venice on a multi-story. It's a 2-story height limit, but it was effectively a 3-story building with a mezzanine and roof decks. And we wanted to have long spans in the building, meaning that there's large openings inside the building that have to be supported by some structure. And usually when you do that, you have to have steel beams and custom steel frame building. And so we were looking to sort of use a kit of parts, as it were. And one of the least expensive building types in America is metal buildings like they use in warehouses and barns and the like. And so after contacting 50 different manufacturers for this project, we found one that helped us to massage the design or to fit the project. And then we found another one who was actually willing to build it after we've done that massage. And because the first one wasn't. And it's a very, very fast assembly of this type of project where the whole building is put together, bolted together in a matter of days, the frame. And then we combined it with other parts, such as insulated metal panel systems like they use in refrigeration units. These were finished with a factory finish, like an automotive finish inside and out, which helped in some areas to be the entire interior and exterior finish, as well as double the insulation that would normally occur in a residential building. And so those are the sorts of things that we did to combine systems, and the roof system came with the metal building, things like that. And so we were able to put that building up for about 2/3 the cost of a custom home. So these are the sorts of approaches that we take. They're innovation. They're using an industrial type of systems for residential buildings, and we are not afraid to investigate, do thorough research, and ensure that these products can be used and built, and they generally far exceed the codes, so that we have great confidence, and we've proven through our actual use and longevity of the buildings that are in place now. We've proven that these work, and they're effective, and they're cost effective, and definitely fire resilient. And I'll let Joseph talk about one of the other systems that we use.
Okay.
Yeah, and so this one was kind of discovered back, by us maybe in 2017 when we had access to this machine. We were approached by a nonprofit because we had done a lot of concrete research and this concrete work, and so they said, "Could you 3D print concrete homes in a foreign country in Armenia?" I'm Armenian, and so a lot of connections in that community, and our response was, well, we don't really do 3D printed concrete homes, but have you seen this machine that prints light gauge steel? And it can print steel based on any geometry, any size that that the design calls for. And so we took them to Orange Coast College, where I teach, and we showed them how this machine can quickly print, manufacture. It punches every hole, it labels every stud, and prints it out for easy kind of screw in place assembly for all of the framing in an entire house. And we showed them how quickly this machine could run, and they said, "Okay, where do we sign? We're gonna use this. This makes much more sense."
Mhm.
And so, and again, for me and Ron, we see this as another means for realizing this idea of mass customization, where
Right.
you're producing in mass quantities, but each one can be different for the same
Mhm.
price and the same
That's
cost
good.
as the original
Mhm.
design. So
Mhm.
we see this as a way of getting over that hurdle of repetition and allowing for each house to be different, each
Mhm.
design to have its own character and be designed based on the client's needs, which
Mhm.
every architect strives for.
Right.
So we propose that delivery system, and there's a number of machines out there that do this. There's one called FrameCAD, another one called Howick, and we use these systems to design and deliver houses to Armenia. So
Um,
there was an earthquake in '88 in Armenia, and international, a lot of their structures collapsed. A lot of these old Soviet era concrete,
mhm.
unreinforced, poor, concrete block structures
Mhm.
collapsed. And after the earthquake, international aid groups from all over the world sent shipping containers full of food for the families to survive. But after the food ran out, they ended up living in these steel shipping containers. And so to this day, there's still shipping containers that dot the countryside of families living in these really shanty towns outside of the capital of Yerevan, which looks like any other European city. It looks beautiful, but if you go into the countryside, there's still a huge need for housing following that catastrophe. And so we said, well, what if we could print the steel houses here, put it on a shipping container, and send it over? We discovered it'd be $10,000 to ship it. We said, well, what if we find a company more local that could print the houses there, and we just send a digital file and they print it.
Mhm. Mhm.
What's nice about the FrameCAD system is that it's pre-engineered, so you're designing something with a known material in a known uh, earthquake zone with known building code. So all of those are inputs that you could put into the software. And so every wall, every truss of the house is going to be pre-engineered. And so you get a kind of a cut sheet of information when you plug it into the software, and it'll say, does this wall pass or fail? And it'll tell you right there. So the
Ah.
structural engineer is still needed, but they verify the report that the software generates. And
Mhm.
so that streamlines the process as well. And so we worked with a consultant based in Melbourne. Um, he basically took the digital file that we had, converted it to a FrameCAD file,
Mhm.
and converted that. So we had a file to send. We found a company in Romania that would print all the steel and then ship it to Armenia. So we did that for the first few houses. More recently, we found a company in Armenia with two machines, and they've been able to print locally. And so
Right.
it's cutting down on the shipping costs, and we can print directly right there. And what's nice about the system is that every steel part only fits together one way. So often,
Mhm.
if you're designing in a foreign country, there's always the risk of improvisation and contractors building with the methods they know and doing things a different way. With this, it all fits together like an erector set or a set of Lego. And
Mhm.
so you just give them an assembly set of drawings, and every wall has its own little assembly sheet. Everything is labeled, and it makes assembly much more streamlined. So now we've built 9 houses in Armenia using this system.
Wow.
It's allowed us to be very nimble. The first house we framed in 3 days. That's with the language barrier and volunteer labor that didn't have much experience in construction. So it was a hurdle, but I think through technology and this design process, we're able to overcome some of these challenges of building in a foreign country, building
Mhm.
with a system that they're not familiar with.
Mhm.
And so after this, we've realized, this doesn't just make sense for foreign countries or disaster relief scenarios. This makes sense here.
Anywhere.
So it's about
Mhm.
getting the U.S. to adopt
Mhm.
these systems, and the roadmap is there. I think our industry is it's ready, these industries are ready for an overhaul. The wood frame industry is still very prevalent, and I think controls a lot of what gets built. And when most contractors hear of light gauge steel and steel framing, they think of the noise associated with cutting steel, the sparks and abrasive nature of it. But they don't realize that with this system, there is no cutting in the field. Everything just snaps into place and gets screwed together. So whereas a normal wood frame job site, if you're lucky, you'll see about 10% construction waste for wood frame. You get zero construction waste with this system. Everything is done all the walls and trusses are printed and framed in a factory, brought to the site on a flatbed truck and tilted into place where the rest of the finishes are installed. So in response to the recent Palisades and Altadena fires, we're suggesting this is one of the many solutions that can reduce the time on the job site, reduce the dependence on skilled labor so that, volunteers can build these kind of structures. We're also talking to Habitat for Humanity and World Vision to kind of be one of the many tools that they have in their arsenal to rebuild homes.
Yeah, it sounds like there's endless possibilities for you. And I remember when I first met you at the workshop, I was asking you because you mentioned the Armenian projects and I like, are you shipping the frames over to Armenia? And I that was one of my big first question, like how do you source the steel? And you mentioned that you can basically source the steel locally anywhere you are building. Is that correct?
Exactly, yeah. So the steel is sent in a giant coil, so it's
Hmm.
like unrolling a giant fruit roll up. And so you unroll it, and then the machine bends it into the C
Hmm.
channel profile and
Yeah.
labels it, punches it, cuts it. So yeah, those coils of steel could be delivered anywhere. The frame CAD company is based in New Zealand, but
Hmm.
uh, you know, they have headquarters all over the world. So
Hmm.
yeah, you'll see it a lot more in Europe and the Middle East and Asia, but the U.S. I think we're so dependent on our wood frame industry. It's been slow to
Right.
adopt, even though light gauge steel is in the building code and it's been there for a while. It's just we've been accustomed to you know designing a certain way, and I think
Hmm.
generally it's the architects that are the ones that are going to push the envelope and force the other
Right.
members of the building team
Right.
to innovate, because a lot of people like to do what they're used to and build in traditional ways. We see this as a new technology to help us build new forms of architecture,
Hmm.
not just build the same thing that we've been building for over 100 years.
Yeah. Now, I know that you have been using like some type of SIP to go with your framing, and I also saw that you have cross laminated timber, and you implement these different materials. And how does it work in terms of the code? Like, do you have already kind of a streamlined process of getting your projects passed through the code, the permitting process?
So all of these systems are permitted in the same way as
Mm,
any other kind of building
okay.
system.
Mm-hmm.
Some of them have some engineering that are done
Mm-hmm.
out by the fabricators themselves. But
Mm-hmm.
there's always a project engineer who's
Mm-hmm.
responsible for the whole building, and
Mm-hmm.
they ensure that everything is not just in compliance with the code, it exceeds the code.
Mm-hmm.
They have to do that for seismic
Right.
reasons,
Right.
and ensuring that all of the vertical loads, that are working properly. So
Mm-hmm.
we've never had an issue with the code,
Mm-hmm.
in terms of making any of these things comply, because
Mm-hmm.
they're already in the code.
Okay.
Um, and it's not like modular home building where building is inspected off-site and brought to the site, right?
Mm.
And this is all inspected on-site in a conventional process,
Mm-hmm.
and it doesn't um, in no way is a modular building that sometimes only have to comply to HUD standards, which means
Mm-hmm.
that it would show on your title report
Mm-hmm.
that you have a modular or prefabricated home.
Mm-hmm.
These are not that. These are panelized or kit of parts systems that are all installed, assembled, built in somewhat conventional ways on site.
Mm-hmm.
It's just faster, better, stronger, you
Mm-hmm.
know, using
So,
using no less combustible, and even the CLT, the cross-laminated timber,
mm-hmm.
is in the code as a fire resistant construction, because the outer layer will char, but they
Mm-hmm.
won't burn through in
Right,
conventional
right.
wood. Yeah, so all of these systems that we employ are so much better than conventional framing, and having dealt with conventional framing for decades, I can tell
Mm-hmm.
you without hesitation that is the case.
Right, right. So how much faster, like compared to like say prefabs, like a modularized prefab or panelized prefab, they usually say they can put a house together like in 48 hours or something like that.
Yeah, but what is the time in the factory?
Right,
That's
right,
the
right,
question, right?
right.
Yeah,
Mm-hmm.
and so we have seen on-site construction
Mm-hmm.
for between 6 and 8 months.
Mm-hmm.
Um, but of course, those are not guarantees because we're not the builders.
And that's
So
including the site work though, right? Like,
that's right.
right? Okay.
That's right. Yeah.
Yeah.
Yeah. But a conventional home
Mm-hmm.
of 2 to 4,000 square feet,
Mm-hmm.
we often see those as being 1.5 to 2 years of
Mm-hmm. Yeah.
construction.
Yeah. Yeah.
And so this is much faster.
Mm-hmm.
As an example, with the panelized computational framing, we're using the steel stud system.
Mm-hmm.
Those are assembled in the factory in a couple of weeks. The panels,
Mm-hmm.
they get on the job site,
Mm-hmm.
because they're all panelized, and the contractors just have to bolt them down and screw them together. They see assembly in 3 or 4 days for a house, sometimes two-story houses,
Mm-hmm.
and then a lot of the rest of the work is fairly conventional, but we see houses being framed in a couple of months, usual, but it doesn't stop there.
Mm-hmm.
With wood frame construction for a single family, or even multifamily, there's something called back framing, and
Mm.
that's when there's these bits and pieces that get installed for blocking. It's for fire blocking, to keep fire from going from one cavity to
Mm-hmm.
another. Backing for grab bars and handrails, little odds and ends that continually go on over the course of a
Mm-hmm.
month or two
Mm-hmm.
as other things are happening.
Mm-hmm.
The plumber has to drill holes through all of the studs to get plumbing through, or joists, and the electrician has to do the same thing to run all their wires. All the holes have to be drilled.
Mm-hmm.
The prefabricated pieces already come drilled and punched, ready for all of those components,
Mm-hmm.
and there is no back framing. It's all of those pieces that are required are designed and assembled in the factory
Mm-hmm.
prior to those coming out. But again, even though it's assembled in the factory, it all is visible and inspected on site by the building engineer.
I
So there's
see.
nothing concealed.
I see.
So
So, do you have any challenges that you are confronting in terms of, you know, moving this, what you are doing forward in terms of having it known, or, or any other, say, like regulational obstacles or anything like that you are facing?
Code compliance doesn't seem to be an issue. I think the biggest thing is getting the word out to other
Mm-hmm.
contractors, and also having contractors with experience in
Right.
this. I think a lot of them just have wood frame
Yeah.
experience, so
Yeah.
it's harder for them to kind of get out of their comfort zone a little bit. But
Yeah.
once they see how quickly it assembles, and that it's not the traditional light gauge steel that you have to cut to size on site,
Mm-hmm.
I think it's just a matter of time before more adopt it.
Right.
And typically it's contractors that own these machines, and they'll use them to print and frame. But a lot of the ones that do have these machines don't want to publicize it because it's kind of their secret weapon. So we see this Apple, could be applied to residential, commercial, tenant fit outs, things like that.
As I said, I'm not an architect or engineer or anything technical like that, but as in general, when we are all working hard to decarbonize and make our structures 21st century ready or even beyond, I see that the main obstacles are really to educate the contractors and even at small levels like plumbing and electricians to really adapt to new technologies. So I would imagine that educating or informing the general contractors are probably the biggest, if not a challenge, but it could be the biggest task for you guys
Right.
to like educate them.
It is. It is.
And you were saying that it's not that complicated, right? Like
Yeah.
how much trainings does one need to have if you are already seasoned contractors? What do they have to do to learn what you guys are doing and be able to implement in their projects?
All they have to do is read the drawings. That's it. Because it's very simple.
As far as assembly, it's really unlearning all of the things that they've had to come up with. With light gauge steel, all the holes are pre-punched, so it's just lining two things up and screwing the hole, lining the holes up. We've worked with students that had zero construction experience, but we showed them how to use a screw gun, and they're able to assemble.
Oh wow, that sounds fun, actually.
Yeah, it is fun.
And one of the things I would say, in addition to educating contractors, it's really contractors will do what the client needs. And if the client says, this is what I want for you to build my home out of, because it's going to be better, it's going to be more fire resilient, it's going to be termite free, all of those things, it will never rot. We will avoid all of those pitfalls that we have with wood frame construction. It will last far longer and be stronger. If this is what I want you to build my home out of, the contractor will do that. So I think a lot of it has to educate the homeowners, the people that need to build new homes and rebuild the homes after these two fires that we've just had.
What would be your elevator pitch if you were to give a homeowner to consider your design?
Well, I think it would be faster, better, stronger, and generally less expensive.
I was speaking to another architect recently, and he was saying, "Do you really want to take on all of these projects? It's just going to be they're going to want traditional architecture." And I said, "No, it's actually quite the contrary. Everyone is requiring something different. They want something that has better resiliency in mind as a benchmark, not just something that's added." So I see this as a big design opportunity to solve a lot of these problems that architects have been pushing for a long time, but now it's on the forefront of everyone's minds.
Yeah. Okay, so what is your vision, both of you? Like, if you have any big vision you can share with me, how you see buildings space evolving into as we move in more into the century in 21st century. What do you envision?
That's a great question. I think for us, we're always inspired by nature and using nature as a starting point. So we can use the most advanced technology, whether it's robotics or parametric design, using algorithms, AI. Regardless of the technology, our goal is to create something that's beautiful and it just works as far as simplicity and there's kind of a synergy in the work that we do. So we're hoping to use this advanced technology to create beautiful forms in nature and having everything work together really well.
I love that. How about you, Ron?
And well, I think that we touched upon this as the idea of building differently, that buildings that work better and respond better to their environment. And so, this is not a new problem. This is something that was tackled by the modernists in the mid-century, and we can see a lot of those structures now are becoming very desirable because of their simplicity, the way they bring so much light into buildings, into the interior, the way that they are really kind of machines for living in a better way. And modern design is, as Joseph mentioned, not additive, meaning we're not putting ornamentation on top of a structure of a building. We're expressing structure. We're expressing the natural beauty of the way that the building is designed. So it has sort of an elegant simplicity to it. And so I think those are our visions for design and for enabling people to live better in that way. Also with a good connection to the exterior. We're in Southern California. We want to really promote indoor outdoor living. And it's very healthful to do that. To be able to even if you don't go outside right away, but you feel like you're outside, and it's easy to entertain outside, and the building should be able to respond to those needs. So those are the sorts of things that we think about.
We talk about this idea of design elegance a lot, where rather than elegance as this ornamentation idea, but elegance as in one thing serving many purposes, kind of like the way mathematics approaches elegance. It's an elegant solution. And so we try to do that in the architecture where, it's not just a load-bearing wall, it's something that's organically designed and, becomes the overhang and things that merge into each other. Again, one object serving multiple purposes, and we try to find opportunities for that.
I really love that simplicity. So tell us how people can find you guys.
Yeah, we're on social media. So our Instagram is @FormFoundDesign. We're also on LinkedIn, Facebook, TikTok, all under Form Found Design.
The Form Found Design.
Yeah.
That's the handle.
There's two D's back to back in the name when you type it. So,
That's right. I noticed
Found
that.
Design.
Yes.
And so we have to do that. And also on our website, formfounddesign.com. And you can reach us through email from that website as well.
Great. Well, thank you so much, Joseph and Ron. It was really fascinating to hear your stories, and I really love what you guys are doing, and I hope to be able to promote you guys.
Thank you so much. We appreciate the time and look forward to doing more of these.
Yeah. Thank you so much. This was Izumi Tanaka with Home Green Home Podcast. Until my next episode.